4 kilometers down, in total darkness, oxygen is rising. It shouldn't exist. This is still unexplained. The science that hasn't finished arguing. Oxygen on Earth comes from photosynthesis, from plants and sunlight. But here, 4 kilometers down, there is no light. So where is this oxygen coming from? The team's bold explanation. These nodules act like natural batteries, generating enough voltage to split seawater. But the claim is so strange that many scientists are skeptical. These potato-sized rocks are rich in manganese, nickel, cobalt, and copper, metals for batteries and solar panels. And they're the target of a multi-billion-dollar mining industry. The Clarion-Clipperton Zone holds enough nodules to power the green transition for decades. But if these same rocks are also making oxygen, mining them could destroy a process we don't yet understand. In sealed chambers on the sea floor, oxygen readings climbed, again and again. They recalibrated instruments, checked for leaks, and still the oxygen kept rising. Their hypothesis: tiny voltage differences on nodule surfaces split seawater into hydrogen and oxygen, a process never before observed in nature. Published in Nature Geoscience, the data showed oxygen rising steadily, challenging the idea that all free oxygen comes from photosynthesis. A new source of oxygen on Earth? The scientific community erupted, and a mining company had a very different story. The Metals Company, a deep-sea mining firm, helped fund the research. Now they call it a mistake. Trapped air bubbles and faulty instruments, not real oxygen. In their own trials, chambers without nodules also saw oxygen rise. That, they argue, proves the nodules can't be the source. It's just an artifact. In their 2025 rebuttal, the Metals Company argues dark oxygen is an artifact, trapped air bubbles, and instrument drift, not a real phenomenon. The debate is fierce. Researchers split on both sides. The question remains open. If dark oxygen is real, mining could destroy a process we barely understand. But the implications go beyond Earth. On Enceladus and Europa, hidden oceans lie under miles of ice. Could rocks make oxygen there, powering life without stars? Astrobiologists are rethinking where life could exist. Regulators are weighing the risks. The 2026 expedition may settle the debate, or open an even deeper mystery. In 2026, with Nippon Foundation funding, Sweetman's team will lower new instruments to settle it. It began with a routine experiment. Sweetman's team sealed chambers on the sea floor to measure how much oxygen deep-sea life consumes. But instead of decreasing, oxygen levels rose slowly, steadily, impossibly. They recalibrated, checked for leaks, and repeated the tests. The result held. Something down there was producing oxygen, and it wasn't photosynthesis. The seafloor of the Clarion-Clipperton Zone is littered with nodules, potato-sized rocks. They form over millions of years as metals precipitate from seawater. Each holds manganese, nickel, cobalt, copper, and lithium. And they might be doing something no one ever imagined. Sweetman's team measured tiny voltages on the nodule surfaces, up to nearly a volt, similar to an AA battery. In theory, these voltages could split water molecules, releasing oxygen and hydrogen. It's electrolysis, but no one had ever seen it happen naturally. The idea stunned even the researchers. But the scientific community pushed back. Some argued the oxygen could come from trapped air bubbles in the chambers, or from instrument drift. Others said the voltage measurements were too small to drive electrolysis. The debate grew heated, with researchers taking sides. The claim was extraordinary, And extraordinary claims demand extraordinary evidence. Why does this matter beyond science? The Clarion-Clipperton Zone is a mining frontier. The metals company has spent billions targeting those exact nodules. If dark oxygen is real, mining could disrupt a fundamental process. If it's an artifact, extraction is clear. The stakes couldn't be higher. Here's the twist. The firm partially funded Sweetman's research. When the results came out, they turned on the science. Critics call it a conflict of interest. The company insists they're just following the data. Is their rebuttal driven by science or the bottom line? Science relies on replication. If other labs can't reproduce the dark oxygen effect, the claim weakens. But replicating deep-sea conditions is incredibly difficult. You need the same pressure, temperature, and nodule types. So far, no independent team has confirmed the finding. The 2026 expedition is the first serious attempt. This debate isn't just academic. The International Seabed Authority is drafting mining rules. If dark oxygen is real, those rules might need to protect the nodules as a life support system. Some countries already call for a moratorium. The science could change the fate of the ocean floor. The nodules aren't just rocks, they're habitats. Sponges, sea anemones, and tiny worms cling to their surfaces. Some scientists worry that mining would wipe out these communities before we even know what they do. If the nodules are also producing oxygen, the loss could ripple through the entire deep-sea ecosystem. The implications stretch beyond Earth. On Europa and Enceladus, salty oceans lie beneath thick ice. If rocks can make oxygen without sunlight, those moons might have a life-giving ingredient. Scientists are already planning missions to search for this kind of electrolysis. Dark oxygen could rewrite the rules of habitability. Sweetman's 2026 expedition, funded by the Nippon Foundation, will use improved instruments to avoid the artifacts critics pointed out. They'll sample more sites, monitor for longer, and check for trapped bubbles. If oxygen still rises, the evidence becomes much harder to dismiss. Until then, the scientific community waits. The debate continues in papers and conferences. Mining companies push forward with extraction plans, and the deep sea keeps its secrets. The next chapter is coming, and it could change how we see our own planet. But how do you prove a rock is a battery? Sweetman's team ran a controlled experiment. They placed nodules in seawater, measured the voltage, and watched for gas bubbles. Tiny currents flowed, and oxygen appeared. Not proof, but a hint that the geobattery idea wasn't just fantasy. Meanwhile, the mining industry isn't waiting. Prototype collectors have already crawled the sea floor, sucking up nodules and sediment. The first test in 2021 kicked up a plume that drifted for kilometers. If this becomes routine, the dark oxygen process could be smothered before we ever understand it. The abyss keeps its secret, for now. The universe keeps refusing clean answers. Subscribe and meet the next one. Nothing about sperm. Whales is normal.